Okay, hi everyone. I think we are live. So this is a Geobear webinar, and this is part of a webinar series we're running most weeks now. Started just when the coronavirus pandemic kicked in and everyone was working from home. But we found this is a useful forum for people to learn a bit about Geobear and our solutions. And this one specifically is how we work on social housing and treat subsidence on social housing. With me today is James Wilson. You can see James in the corner there. He's going to take you through the presentation. I'm just going to dip in and out, adding some videos when necessary, and then I'll be back at the end. There's a chat box at the bottom right-hand corner, and if you've got any questions, type them there. By all means, type them as we go through, but we'll probably pick those up towards the end. So without further ado, James, we may as well go straight over to you. We'll probably turn our cameras off just to save bandwidth. So I'll disappear now and leave you to it, James. Thanks.
Okie dokie. Yeah, welcome everyone. So yeah, as Alistair said, my name's James Wilson. I'm an area manager at Geobear. And what we do is we are a specialist company that deal with subsidence. And what I'm going to try and talk to you about today is our subsidence solution specifically for social housing. We work in a lot of sectors. Social housing is one of them that we work in. So I'm just going to specifically talk about the work we're doing in social housing and how that might be of interest to you. So firstly, what is subsidence? So for those that don't know, I'm sure you all do, but subsidence is the downward movement of foundations, put very simply, and it's characterized by these diagonal type cracks that sort of are most evident around openings like windows and doors, and you usually get them through the mortar, like you can see on this brick course here, underneath a window, go into a lintel over a door. And you can see in this left picture, that's obviously on the inside of a property, and you get that diagonal crack. That's really common. So that's what it looks like in its sort of normal form. But it can get really bad. If it's left for a long period of time, it can get really, really bad. Here's a house in North London. And this is really bad. This whole rear outrigger is now moving right away from the structure. And you can see they've had to actually hold it up with wooden props. It's moved so much. So if you leave it a long time, it can get really, really bad. And actually the work now to remedy this is very expensive because they're going to have to demolish the whole sort of rear outrigger and actually rebuild it. So leaving it for a long time can have sort of massive consequences. And also it's a big shame when you've got houses like this in an area of housing that's, you know, great need for housing in North London. And you've got houses like this that are just left void because the subsidence has been allowed to deteriorate over the time, you know, when that house could be used to, you know, for much needed social housing. So what's the cause of it? So there's lots of causes. The most common one, which sees about 70% of instances of subsidence, is clay soils and nearby trees. So trees taking the moisture out of the soil underneath foundations, causing a shrinkage of the clay, and then the foundations then go down on that shrunken volume. That will vary with seasons. So in the winter, the clay swells as there's more rainfall, more water in the clay. And then in the summer, when it's hotter, there's less water, and that clay will shrink and the foundations will go down. And then leaking drains as well is a big cause. Washing more in granular soil, but it can be in clay soils as well, where leaking drains can cause local strength deficiencies underneath foundations. And then just settlement, that's really only in granular soil, but if the soil just settles over time, in like a made ground type of soil, or there's just a water leak of any kind, like the incoming water pipe bursts or something. There's other causes, but let's say they're the main ones. And then why would you solve it, I suppose? Well, it's unsightly. You know, if you ever had it in your own house, it's unsightly, and people have a huge concern. You know, it's people think the house might fall down. It very rarely happens, but it's a great concern to a lot of people who live there. And then you've got obviously this disrepair law that's come in fairly recently that can tenants can actually bring claims against housing providers where the house is in a state of disrepair, and often subsidence is a big factor in that often. And then sticking doors, a big evidence of subsidence actually happening is like sticking doors and windows. If you can't open the door properly, so that can actually be a fire risk. Then if people can't, it's difficult to open doors because of the subsidence. And then cost increases with time. That's a really big one, because as you saw with that previous slide, that subsidence has been going on for a number of years. Now the cost to remedy that is hundreds of thousands of pounds, because you've got to rebuild that whole part of the house. If they'd done that earlier, so if they'd actually taken proactive steps earlier, then the cost to actually remedy that subsidence would be much less. So the cost increases with time, and then it's worthless. If you ever tried to sell a house for subsidence, you can't get a mortgage on a house for subsidence. People won't buy it, so the asset's sort of like worthless. And then, as I mentioned before, housing crisis. You can't let houses with really bad subsidence. So solving subsidence goes some way to alleviating the housing crisis. Is there a better way? I mean, this is quite a dramatic photo. So is there a better way to solve it? So the standard approach is like underpinning, which is where you remove the soil that's weak or damaged or shrinking underneath the foundations. And you either underpin it, which is where you replace that soil with concrete to a greater depth, or you pile it. But either of those two options is incredibly disruptive. So you can see this person's house here. They've had to dig out all the soil underneath the foundations. Massively disruptive to the person living here. Very expensive to the person who's paying it. And so is there a better way to do it? Obviously, we think there is, which is why we set up our company some 30, 40 years ago. And what we do is specialist geopolymer injection. So where things like underpinning and piling is you're replacing the damaged soil, or you're extending the depth of the foundations. What we do is we improve the soil that's already there. So we don't remove the soil, we leave it there, but we improve the soil that's there. And it works on a whole different types of soils. We investigate everything, and we work out what is the right solution. But basically, the science behind it is that it's a two-component material. So it's two types of material that we inject straight through the strip footing. So you can see this picture on the right is a very standard strip footing, and this is a color-coded sort of finite element analysis of the soil underneath the strip footing. So we stand on the surface here and we drill down and we inject a two-component material directly underneath the strip footing to whatever depth we determine is necessary. And then we pump this resin in, and those two materials, when they start to react in the soil, over a period of just a few minutes, well, 30 to 60 seconds to a few minutes, they expand and they harden rapidly. So you can see this is the strength of the soil. It's sort of purples at its very weakest, down to sort of dark reds at the very strongest. So you can see what we've done here is underneath this strip footing, by injecting our resin, we've increased locally the strength of the soil underneath the foundation. And that strengthens and it stabilizes the soil as well, so it stops it from shrinking and swelling. And then so the reaction, depending on the resin we use, happens in between sort of 60 seconds to a few minutes. So it happens all very, very quickly. And the material expands with such a great force that it actually can lift structures up. So rather than digging the material out, so there's no excavation, we're just drilling little holes and we're injecting a resin to the depth. So Alice, if you can just play that video that's associated to that. So just to give you an idea of what the resin actually looks like, this is just a trough. And it doesn't look like this when you're injecting it into soil, but this is how it looks like. It's just injected in into a trough. So it expands rapidly and then hardens within just a few seconds. and it almost looks like a foam type of material when it's hardened. So you can just see that again. So if you can just go back to the presentation, Alice, that'd be great. So that's how it looks when it's sort of in an open air in sort of a trough, just to see what the material actually looks like. But the question is, how does that actually work on a house? So what does that look like when you install it on a house? So in some ways, it's quite easy to understand how that might work in a granular type soil, where it's sandy and gravelly and there's little voids and stuff. So I'll just show you how it might work in that circumstance. So Alice, if you can just play that video, please. So we stand on the surface, so out here, and we drill down here. This you can see where we're drilling down to whatever depth we need. We inject the resin, it fills those voids, expands, pushes the strip footing back up. So I'll just quickly play that again. So we drill down, inject the resin from the surface into the granular soil. The resin expands, hardens rapidly, and pushes the strip footing back up. So that's quite a quick, but that's been the historical use for sort of 20, 30 years of the product. And I'll come into a bit later how that works more in clay, but the basic principle is that the material expands, it moves to the path of least resistance. As it expands, it pushes the soil out, hardens rapidly, and then increases the strength of the soil underneath the strip footing. And then in terms of the whole process, so because we're not doing any digging, there's a whole load of things that we don't have to do. So the mobilization to site and the completion of the works is a lot quicker than the normal process. So if you take something like week 0 would be an instruction from yourselves, from a council, from a housing association, to come to site, and then we would inspect it. So we would come to site, we would inspect it, we would see where the property is subsiding. We would do things like site investigations, where we would take a borehole, we'd dig a trial pit, and we'd see actually what has caused the subsidence. And we'd take all that information. We'd also do things like drain surveys to see if they're causing any issue. We'd then take all that information, we'd design a scheme, and we have an in-house design team which would do that. Someone like me would be the person who would actually inspect the house in the first instance. And then our team of designers would verify that design and complete a design. And then we would quote it, and then within 3 to 4 weeks of that initial instruction, we could mobilize a team to site to actually do the works. And most jobs on a standard house, most jobs are between 1 and 2 days. So we can solve the subsidence in just 1 or 2 days from arriving on site. So within 3 to 4 weeks of initial instruction, you can have it stable. Drains are monitored, and then we would undertake a completion and verification of the project just after we've done it. So we would do another soil strength test after the works, just to verify how we've increased the strength of the soil. And then about another month after that, you would get the guarantee for the works. So insurance-backed guarantee, certificate of structural adequacy, to say that's then achieved what it was meant to. So the substance is now sold. We've got the paperwork to prove that. And then that's fully transferable. So if you ever sold the house, you could actually transfer that to anyone you needed to. So the big question about clay. So I've sort of gone through the more, let's say, easier bit to understand, which is how it works in granular soil. So fill in those little voids, fill in those little gaps in the clay, in the granular soil, and expanding out and increasing the strength of the soil. But clay shrinkage is the much bigger issue that there's certainly in the UK anyway that housing companies face. So this is specifically what we do for clay. So the whole process, if you just saw that video, so that's great. So this is an animation, obviously, of how we undertake clay treatment. So this is a fairly standard detached house with a tree out the back, a tree out the front here, and you've got one corner of the house that's got subsidence from probably this tree. So there you can see the standard sort of diagonal cracking in the mortar. That's absolutely common thing that you see all the time, caused by this clay shrinking with the tree root. So we'd come along, do our survey, then we'd do some site investigation. So we dig a trial pit, see that it's a strip footing, and then we drill a borehole into the soil, analyze where the root depth, where the depth of the roots is that is causing the subsidence. Then we'd analyze that, and then we'd come up with a design. So our design would be to inject the resin at certain intervals around the strip footing. So we drill from the surface directly through the strip footing to the depth that we determined by the site investigation information and the lab tests. Then we'd insert injection tubes. And what happens when clay shrinks? You get these horizontal and vertical cracks and fissures in the clay. So where it's just dried out, you can see it from the surface sometimes. Maybe in your back garden, if you're in a clay area of the UK, you can see those cracks in the garden where the clay is just dried out. So the first thing is the resin will permeate and go into and fill all those sort of cracks and fissures in the clay. That's sort of fairly easy to understand. You can see that happening here. But then as the material expands, it squeezes the layers together of the clay and it drives the moisture out. And that moisture is then replaced with our resin that's then there permanently. And it can't be taken in and out by those trees that are there. I'll just go back to that. So the resin can't be taken in and out by the trees because it's a permanent thing and it's there forever. So that clay is now stable. So you're basically effectively reducing the plasticity, the shrinkability of the clay to a much more acceptable level. So you can then come along afterwards, you can repair these cracks and, provided the tree roots don't go any deeper than they have when we did the works, you would be fine. But another advantage as well is you wouldn't necessarily have to remove that tree. So you can see that you can just go back to that video. Sorry, Alistair. So I'll just quickly skip on. So if you can just see so you can see you have root depths here. You have the depth of the roots. As long as those roots don't increase in depth over time, this is a permanent solution. And then the roots are still there, but they can't have that shrinking effect on the clay because you've put so much resin in there that you've changed the shrinkability of the clay. I'll just take that to the end, and then, as I say, you fix the cracks and you move on. So the tree can still remain. So ecologically, it's much better. Councils don't have to spend money chopping trees down, which, as everyone knows, is a bit of a bane on the council's finances because they have to constantly pay to chop trees down. So in terms of when we've done this, so just run through a couple of case studies. So I've got 2 case studies here. Both were projects that I did. This client was Hammersmith and Fulham. This is a council property in West London, and it was living in there was a single parent with young children. So they had a drain failure. I don't know if you can see. So this is my treatment plan here. They had a drain failure. So that drain was leaking water out into the soil underneath, and it was causing weaknesses in the soil. We came along, we inspected it, we did a drain survey to see the condition of the drains. We noticed there was a problem with the drains, that was going to be causing the subsidence. So we arranged with the client to repair the drains, and then we came along and we injected all around the rear outrigger of this property, injected our resin underneath the foundations, and then that was fully stabilized. So that took us about a day to do, a bit less than a day, and we had to do some work in advance of that to repair drains, but basically it was fixed within a day. Whereas any sort of traditional approach, traditional approach to this would be to dig out all this foundation and then replace it with concrete. That would take something like 2 weeks, and you'd probably have to move the single parent, the young children out, which is a huge inconvenience to their life. So this just avoids that totally. Another property we did, this is up in Oxford. So this is a more standard clay shrinking problem. You've got clay soils in Oxford. You've got a big tree just outside the back of this block of council properties. So there's actually 2 blocks, and you see there's 3 floors there, and there was about 2 to 3 properties per floor. So there's something like 9 properties per block. So there's about 18 properties. So a lot of families living in these 2 blocks, and they had clay shrinkage. They had this sort of cracking. It's fairly standard subsidence cracking. We came along. We did a site investigation to see the depth that the roots of these trees, see the depth that they're at. We designed our scheme. This is one of our technicians with his injection tubes. You can see they drive these injection tubes down to the depth. And you can see him there. He's injecting our resin, 2 components. You see two hoses there. You're injecting the 2 different components to the depth, and there's someone monitoring the drains. So we had that done in 5 days. Those whole blocks stabilized, whereas any sort of traditional approach would take 4 weeks, much greater cost. But yeah, so it was a huge advantage to Oxford City Council. They didn't have to move all these families out. Finding alternative accommodation for 18 households is quite severe. So this really just totally avoided that. So the benefits. So I've tried to touch on the benefits as I've been going along, but just to really summarize what I'm saying. So the main thing is it's how quick it is. So as most properties take sort of one to 2 days. But the worst, that Oxford one was 5 days because it was the whole blocks. But anything, it's far less time than any sort of traditional approach. We're on site very quickly because we don't need things like building control, because we're not doing any digging. We don't need party wall agreements for the same sort of reason. There's no excavation. You save massive. You save loads of time, so we can be on site so quickly, and we can have it solved with minimal disruption to the residents. So people don't have to move out. People aren't having big skips outside the property where you've got to cart all the soil away. You just totally avoid all of that with what we do. Then also it saves money. It saves money both on the upfront direct costs of the solution, but it also saves money long term because you don't have to move people out, because you don't have to reinstate the whole garden, you don't have to rebuild all their floors and these sorts of things. And then you get a full insurance back guarantee as well. So the next one. So then who have we done this for? So a big market is the insurance sector. So we do a lot of work for insurance companies. Sedgwick or Loss Adjuster Legal and General Insurance Company. And we've won industry awards for this because basically it massively reduces the claims cycle. So previously, when people were monitoring cracks for a long time, fighting with tree owners to get trees removed, that process takes months, years. We can come in while the tree's still there, get it solved very quickly, and everyone's happy and everyone saves money in the long term. Housing associations, councils like Hammersmith and Fulham, like Notting Hill, we've done projects for, engineers, surveyors, and then large contractors, so contractors that have maintenance frameworks for lots of housing association properties or council properties. They could have subsidence in some of their properties, so we work for a lot of contractors. MOD we do work for. They've got a huge amount of housing all over the UK in various states of disrepair. And then loss adjusters and insurance companies. So overall, we've treated about 10,000 sites in the UK. and 200 projects. So this isn't a new development. This has been in various amounts of use for 30 to 40 years, but it's over the last sort of 5 years it's become much more prominent. And then we've done, as I say, over 500 social housing projects since 2017. And just a little bit about who we are. So family owned, as I said, 30, 40 years old, started in Finland actually, but it was franchised around the world. So it's been operated around the world for 30 to 40 years. And then the UK franchise was established in 1985. And then some years ago, about 7 or 8 years ago, we actually brought the contracting in-house. So now it's owned again by the parent company. So now we contract in the UK and a few other countries around the world, contracted ourselves. And it's headquartered in London. And so we're the original founders of this technology. So it actually started in Finland. The original founder, he noticed that he got a contract for a supermarket floor, that the slab on the supermarket floor was just kept subsiding. And this was operational supermarkets. They didn't want to have to decant the whole supermarket and smash up the slab and fill all that, recompact all that soil underneath the supermarket slab. So he invented this resin that he could drill through the slab, inject into the soil underneath it, and re-level the slab back up. And that was the origins of it, and it's just progressed from there into this sort of multi-award winning solution that now works across the board of housing, local authority, social housing, and then infrastructure projects as well, like roads, airports, ports, warehousing, this sort of thing. So that's really it. I mean, there's loads of time for questions, but just in terms of the companies we worked for, numerous contracts like Balfour Beatty, BAM, Mighty, Kia, Volk Fitzpatrick, and then you've got houses at Notting Hill, you've got councils like Hammersmith and Fulham up here, big massive infrastructure providers like Crossrail, and ground engineers like Kelly. We've worked with loads and loads of companies. So basically, please ask all the questions that you have. We've got quite a lot of time for questions, so I'll just sort of hand back to Alison now to field those questions for me. I can see there's quite a few already.
Yeah, thanks a lot, James. That was very interesting indeed. Just to add on your point about Geobear and the UK, some of you might be thinking, well, why isn't this already as widespread as we're sort of making it up? But that was because the previous licensee in the UK, before Geobear bought back the license, they sort of used it as more of a local sort of family and friend operation. So it was just for them, and they didn't really want to grow too much. So obviously, as Geobear could see the benefits for all the councils, and we use it on infrastructure, then we bought this back, and obviously growing it through the likes of people like James to promote us to the likes of you. So that just covers that. And on the social housing side, we've done work all over the UK. Glasgow Housing Association was another one. We did over 40 houses on one very big project there. So it's a very mature solution. But hopefully you've picked up all that from James's presentation. I'm going to read some of these questions out then, James. So this is from Vittorio. How do you control the expansion? So in which way can you determine how much material you have to inject? Is there any risk we create new crack in another area of the building?
Yeah, that's actually a really good question, and I didn't really focus on that. Can people still see my presentation, Alistair? Yeah. Right, so this is quite a good slide that illustrates that. So we know how much the material expands because we know the exact expansion rate of it because we developed the resin. We know how it expands. But also we monitor very, very carefully and with a huge degree of accuracy by how much we lift the structure up. So you can see here on this picture, these are laser monitors. So what we do is where we're injecting, so you can see this technician here is injecting resin. Here you can see him injecting resin there. And directly above him, he's got this laser monitor here. And we project a horizontal laser on that monitor. And as soon as the resin starts to fill all the voids, once it's full all the voids, it's gone through the path of least resistance in the soil. It'll then start to push the structure up, physically push the structure up. And as soon as it does that, we'll start to get a reading on this laser monitor that the soil's now full of resin. So it's now starting to push the structure up. And at that point, we'll either say, right, we'll just stop injecting resin because we know it's full and the soil's stable, or we'll say, right, we want to lift the resin up by, 5 millimeters, 10 millimeters, whatever we want. So we monitor that, and we can monitor that to degrees of millimeters. So we can control the expansion and the rate that expands very, very accurately. So in terms of, can we create new cracks? You wouldn't create it in new areas of the building because the resin isn't really going to travel very far. You might create some other, if you're trying to lift the structure up, if that was the aim of the project, to lift the structure up, you could create some local cracking. But that would just be as you were lifting it up, and then as part of the whole crack repair remedial works that would come along after we'd done our works, you could repair those cracks and they wouldn't come back provided anything didn't change. So I hope that was a good question, because that allowed me to come back to that thing I missed. So I think helps that, Vittorio. If you've got any, if that doesn't, just come back and I'll try and rephrase it.
Yeah, that was good. You might have covered a bit in Craig's question. Could you get differential movement between areas that have not received treatment, i.e. semi-detached dwellings and terraces?
So basically, we'll treat whatever area we think is moving. And what we're doing, our resin will dissipate through the soil to a degree. So what you don't get is those hard spots. So if you're going to underpin a corner of a house, you're going to physically stop that underpinning at a certain point. So underneath the soil, you're going to go from underpin to soil. And that's what's called a hard spot. And what you can get is you can get differential movement in that point that you stop that underpinning. But because our resin dissipates in the soil more gradually, you don't get that hard spot. So you wouldn't expect differential movement. I mean, other areas of the property that we haven't treated may move in the future for another reason, i.e., it's just that's now got subsidence because maybe the tree roots have extended to now affect another part of the property. But if the other area of the property that we decided not to treat, there's no reason why that now would start moving. So no, differential movement isn't an issue.
Great. And what's the maximum size of voids that the injection can fill? Would it be suitable in larger areas with localized sinkholes, etc.?
Yeah, absolutely. I mean, there's no real limit to it. So we filled huge voids. I mean, we're working on some big infrastructure projects that involve huge void fills. Thousands of meters cubed of voids that we're filling with resin, where it's appropriate and where it makes sense to use our product. There's no physical limit to the size of a void we can fill. It's just really a question of economics.
Yeah, and where there is a really enormous volume required, we can combine the geopolymer material with clay sort of lacquer material as well, which would sort that out. But there's a very good video on our YouTube channel about the work we did on the M11, where there was huge voids under the M11, and our material was used to inject and stabilize whole banks of that. So that's worth having a look at, Craig. Question from Alfred: can the same product approach be applied with concrete floor slabs?
Absolutely, yeah. I mean, that's probably my fault. I could have easily put some. We've done as many concrete floor slabs as we have sort of strip footings, and it's actually easier with a concrete floor slab. So yeah, we just drill straight through the floor slab, and we inject our resin beneath that, which then expands, and it's actually much easier to lift and re-level a concrete floor slab because it's an independent thing, and it can just be, usually it can be re-leveled to where it was before the subsidence happened. So yeah, I mean that's a really good question, Alfred. Obviously, I probably could have put that in my presentation, because that's a really common use of the product. Because you can imagine the alternative: if you've got a floor slab that's subsiding, the alternative to drilling little holes and injecting resin underneath it is basically to break out that floor slab, dig that soil out that's been compromised for whatever reason, and replace it with some other aggregate, and then relay a floor slab. So that's hugely disruptive to someone. That's definitely move out and, for a couple of weeks and come back. So that, it's a massive advantage for people like that.
Okay, and you sort of touched on it or alluded to it with the supermarket example when this was originated. This is the most least disruptive solution, and we have done this on commercial floor slabs all across the UK. Accolade Wines in Avonmouth was a massive project, 60,000 square feet, fully loaded racks with wine. Their floor was sinking, and we went in there and did across the whole floor injections to lift that. So we've got plenty of examples anyway. Richard, have you traditionally avoided work in desiccated clays? What has changed? Research, trials? James?
We haven't really. Well, we haven't done any desiccated clay soils historically in the UK. But actually in Southern Europe, we've done a lot. Sorry, I should rephrase that. We haven't done desiccated clay soils in the UK up until about 7-8 years ago. But we've been doing it for about 20 or 30 years in Southern Europe. So about 7 or 8 years ago, we started doing a lot more in the UK. There's a whole host of research and trials and case studies that I'd be very happy to send you, Richard. But basically, we have been doing it for about 20, 30 years. And now it basically forms the massive bulk, majority of what we do, desiccated clays, because it's the biggest cause of subsidence in the UK. So there's a whole host of research that we've done on it, which, I'm very happy to share with you. We've got a load of case studies, and we've done now thousands of properties in desiccated clay soils.
Yeah, James, just to add, that's a question we get asked a lot, and there's a paper coming out. I think it should be in October, which is where we've had some live trials, and an independent consultant company has tested and verified our materials in clay. And just going back to the former licensees in the UK, they typically avoided clay, and they were based in the northwest of England, where it wasn't as prevalent. So historically, they could have probably treated clay, but for whatever reason they didn't. But this is something, high plasticity clays. Obviously, it's a case by case basis, but under 40 pi, then this is.
That sort of leads reasonably nicely into Richard's second question, which is what are the provisos when your system wouldn't work? So the bulk of the research that we've done, almost all the research and case studies we've done, is on clays that have a plasticity of less than 40%. So that would form part of our guarantee, that we would guarantee any work you do on clay that has a plasticity of 40 or less. Above 40, we can still provide a solution, we often do, but there's less research that we've done on those sort of very highly shrinkable clays. So I wouldn't go as far to say that it doesn't work in those soils, because we're doing research at the minute on high PI clays, and the initial results are very positive, but you haven't quite enough to say we're definitely guaranteeing it. So you might say on very highly shrinkable clays, it's not for us, but it doesn't mean it doesn't work. It just means we haven't got a load of research to back it up. But where it doesn't work, it's a matter of depth, I'd say. Where it doesn't mean we've got a sort of limit to how deep we can inject, because we've got to inject materials down an injection tube. And as soon as those materials enter the injection tube at the top, that reaction starts occurring. And we haven't got very long before the reaction actually is complete and the material is then hard. So we've got to actually get that material to where it needs to be in that time. So if we have to inject it at great depth, like 20 meters or something like that, we're going to struggle to get it to the depth as required before it goes rock solid. So if it's too deep, we would struggle to work. Yeah, and so I would say very, very deep, but we can inject definitely to sort of 7 or 8 meters. So 7 or 8 meter depth, covers 95%, probably 99% of subsidence in the UK. There's that odd problem where you've got a sinkhole at 20 meters that our solution might not be the best.
Yeah, James, just to add to that point, James, we've got a secondary sort of product, GORT, and this is a real-time displacement control solution, where it's essentially compensation grouting, where we've designed packers now, where, like James says, there's an issue with the expansion but we can actually inject those at real depths, and that's something that we're working on in the background. It really wouldn't be applicable to residential properties. This is for sort of tunnel boring situations, but that is one for the future as well. There's quite a few questions here, James, so let's try and... So is this suitable for strip foundations and concrete slabs? Only strip foundations and concrete slabs?
I mean, it would work for any residential property, any foundation of a residential property. I can't really think where. I mean, strip foundations and slabs are basically how. I'm trying to think how else. If it was the only other circumstance, I suppose, could be if the residential property was piled and the piling had failed for some reason. But no, I mean, no, it works for any type of foundation. But I mean, strip foundation and slab foundation is basically all the foundations apart from piles. But that's really quite rare for a residential property to be piled. But even if it was piled, we could solve that, because we could inject beneath the piles to strengthen the ground. I mean, I suppose if the piling had failed, it would mean that the piling hadn't gone deep enough. So the bottom of the pile was still in uncompetent soil. So we could inject into that material underneath the pile to strengthen that. So there's no foundation type I've ever come across that we can't deal with. So
no, I think there's an article on our website that covers pads, rafts, the various types of foundation that we provide solutions to. So take a look at the website, Craig, or follow up afterwards, Craig, if you want a separate conversation about any of this.
If Craig's got a specific example, very, very happy. Same with anyone. If you've got a specific example you want us to look at, very happy to. But yes, I mean, strip foundations and concrete slabs is the vast, vast majority of what we do. So yeah, anything else, just let us know. Or let us know.
Do you treat dampness from the ground, asks Hannah.
It would depend. I mean, the material is totally waterproof, so water cannot pass through our resin. So it's often used to seal tunnel linings. You can inject behind things like sheet piling to seal that. So, but it's difficult to provide a total waterproof area. It depends. I'm not exactly sure what Hannah means by treat dampness in the ground. It's not often used to create like a water barrier around the property. I wonder if she means to seal a basement or something.
Yeah, I think that might be the question, and we have done that. We did it recently on a company called Lubrizol in Derbyshire, where they wanted us to water seal the foundations because it was quite a saturated site. So. But maybe, Hannah, give us a bit more context and we'll come back to you on that one.
Yeah.
There's a question here from Chow Min. I think we may have covered this. They're asking about the size of voids, injection range, mention rope cross rail, compensation grouting through shaft, is there limitation size and range for injection? I don't think there is, Chow Min. I think if you can come back to us separately on that. I'm just conscious of time, and that's quite a detailed question, not really relevant to the social housing side. Thomas asks, how do you control the expansion? You mentioned that it follows the path of least resistance, but wouldn't this be below the structure, leading to how can this cause the structure to move back to previous positioning, causing cracks to get smaller?
Yeah, I mean, so how we control the expansion is by knowing how much it expands, and so by these laser monitors. I explained that process just before. So basically, it'll keep filling the soil. So we inject right beneath the strip footing, so it'll fill all the immediate stuff around it, and then as it expands and it can't go anywhere else, it has to start pushing up, and that's how it because we're injecting right beneath the structure, where we know that it's going to at some point push the structure up after it's filled all those little fissures and voids around it. I mean, it sets very quickly, so the expansion is very, very quick. So that means that it can't just like keep, it can't just keep flowing everywhere all around the so it's not going to end up 2 streets down the road, because it's just continued the path of least resistance for half a mile, because the material solidifies very quickly. So it goes in, it sets quickly, expands, and starts to push up the structure. So yeah, I mean, that's sort of it. I mean, basically we've done this thousands of times, and it's that we see this all the time, that it pushes the structure up, and that's how we know that the soil's now full and it's starting to soil's stable. So there's plenty of case studies to know that works.
We've got 29 different materials, and these are all suited to specific soil types as well. So generally, James and our engineering department will know exactly which sort of material they need to use on a specific project. Thomas asks, when you're injecting in areas where tree roots are prominent, as they degrade over time, is it going to create voids in the injected material to cause future issues?
So actually, So basically, with clay shrinkage, it's not the actual presence of the roots. So the physical presence of the roots isn't what causes clay shrinkage. It's those little hair-like fibrous roots that basically suck the moisture out of the clay and then cause it to shrink. So the big chunky roots aren't actually taking the moisture; they're just there, and they'll still be there when we've finished. I mean, the only reason that they would, basically filling all the areas and where the resin then expands and supports the soil. So the big roots aren't really a problem. You haven't chopped the tree down, so the roots are still there. So as they degrade over time, it wouldn't really cause a problem, because that didn't really cause the problem of the subsidence in the first place.
Yeah, and our material's solid. So if those roots did decay, and it would just leave a gap in the material, however big that might be. But these are sort of challenging questions. So
I think you missed Sherwin's. So there's Sherwin's question there about how many floors can this soil be injected. So basically 5 floors is a rough guide, and it's a bit more scientific than that. So we've got specific bearing capacities and strength that we can exert on our material. So roughly 5. So not high-rise build. I wouldn't class it as high-rise. So that's probably another limitation as well. Going back to, I think it was Richard's point of where it doesn't work. So yeah, if it's like a 20-story block of flats, don't come to us. We can't give you a solution for that. But up to 5 floors we can. But that covers the vast majority of residential properties.
Yeah, and the materials we do use for ground strengthening as well. So, for example, there's York Hospital who wanted to put an extra story on an existing part of their hospital, and we strengthened the ground beneath the pads just so they could do that. So it's a really strong material. Yeah. Craig, have you come across issues with local authority building control departments or AIs with regards to site inspections and sign-off?
Building control departments or AIs? I'm not. What's an? Do you know what an AI is, Alistair? You just caught me out there. Probably should know that. But AIs.
AIs. Okay. No, Craig. What do you mean by an AI?
Anyway, so with regards to sign-off inspections, so we aren't required. So we've got a number of responses from building control departments in many councils that say what we do doesn't need building control sign-off. So because what we're doing is we're strengthening the soil beneath the property, we're not extending a property's foundations, we're changing the soil, we're improving the soil underneath a property. So we don't need building control sign off, and we've got a number of statements to that effect. We have had a couple who want to inspect it, but there's no such thing as a real sign off from the building control department. So no, it doesn't happen. We don't need it.
Yeah, Craig, you've got some good questions there. It might be worth having a separate conversation anyway to answer some of those already. Thomas, what's the lifespan of the injected material? 100 years plus. I'll pick that one up quickly.
Yeah, it's design life 100 years. Yeah, yeah. We've never seen it fail. No. We've only been around for 40 years, so we can't see it failing. So the material doesn't deteriorate. Yeah.
Is it safe for the environment, James?
So we've done loads and loads of work on this. So it's got total certification in terms of environmental, in terms of safeness to the environment. One of the things, it's hydrostatic. It can't get into water courses, and it's totally inert once the reaction's occurred. So it's totally safe for the environment. And actually, if you compare it to something like concrete, if you're underpinning, you're pouring a load of concrete, as people may or may not be aware, concrete has a terrible carbon footprint. It's one of the worst contributors to the carbon footprint of the building industry and the construction industry generally. This is a much reduced carbon footprint because, digging out that concrete from places like Portland and the cement is incredibly damaging to the environment. So this just totally avoids that. So the carbon footprint of this is substantially less. So it's much better for the environment. I mean, I guess you're more talking about, is it safe for the environment? So could it damage water courses and stuff like that? The question is definitely not, but it's actually also better for things like carbon footprint.
Yeah, several reports have been done. Environment Agency, I think KLM was the other company, but just to prove our material is inert and doesn't affect the environment. Chow Min comes back for filling a big void is this cost effective? Chow Min, it depends. If it's just a mass void fill, then you're probably better off looking at a different material. We could use our material with clay lacquer, as mentioned earlier, as an option, but this, because the material's really suited to ground improvement jobs, it's not something we tend to use unless there's a structural need. So there was a project in York where the walls of the York Castle, under one of the steps, there's a big void, and they wanted to fill it, but they wanted to fill it with a structural fill to ensure if there was any movement, it wouldn't actually come away from the building. So it really depends on that one, Chow Min, case by case basis, to be honest. So if there is something you're thinking about, though, please get in touch. Likewise, Richard and Craig's approved inspectors.
Approved inspectors, okay, that's one for me. I'll remember that for next time. And then so for void filling, I mean, it depends a lot about the void filling. It depends. I mean, this isn't really a social housing thing because you don't get massive voids under social housing property unless maybe you're in Norwich and it's a sinkhole or something. But it depends about how easy. If the void's really easy to access and it's open and you can just put a load of aggregate in, it's not really very time pressured. Things like where you have a bit massive void under a railway and the access is tight, it's time sensitive because you don't want to shut the railway down for a long time. It's going to be much more cost effective to use us. If you've got an open void in the field that it doesn't matter how long it takes you, the access is really easy. You might be better just filling it with aggregate or something and using it. So it just totally depends on the situation, how big the void is, where it is, what the time pressures are, that sort of thing.
Okay, what is the nature of the gases released during expansion? Don't have that detail to hand, but it's...
I might get back to you on that. I mean, it's not, it's safe for someone to be in the house, but there is some gases released, and when the techs are injecting, they do wear face masks and stuff like that. I don't know the exact nature of the gases released, but we could certainly... So basically, we can do it with the homeowner still there. It's not hazardous for them to be in the house when we're there, but they can't sort of be in the vicinity of the area that we're doing the works.
Yeah.
So basically, we're always doing the work downstairs, but if we have to, usually do it from the inside, but if we have to, usually do it from the outside of the property, but if we have to do it from the inside, the property owner or the tenant, is advised to be sort of upstairs or something, but it's not hazardous if they're upstairs. So but I don't know the exact nature of the gases released, but we can certainly get that information to you.
Yeah, we've got a SHEQ department that has the technical specification of the materials and all of that sort of stuff. But certainly, if there was any toxicity to it, we wouldn't be using it to the extent we are. So, Richard, look out for my email afterwards if you want to reply to me, and then we can maybe discuss that. I think that's about it, James. That was some good questions there. Hopefully we've answered most of them. If not, and you've got a specific issue, reply to my email. James will be copied on it, and between us we'll come back to you. And James is available to come to your office even. I know that we're still in the face mask COVID sort of situation, but generally, people like James and I would be visiting offices to give you this presentation to your teams. So if that sounds like a good idea, let us know. But James, I think that's all from us.
Yeah, I just echo what Alistair said. Yeah, if you have got any projects you want us to take a look at, very, very, very happy to do that. Very easy for us to have a quick look. If you just want to email us any projects, more than happy to have a quick look for you, and we can meet you in person. We cover the whole of the UK and obviously internationally, but this is just about the UK. So anything you want us to take a look at, we can certainly do that anywhere in the UK and Ireland.
Perfect. All right. Well, thanks very much, James. Thanks for the presentation. Thanks everyone for listening and the questions. And sun's shining. Have a nice weekend.
Thank you, everyone.
All the best.
Cheers. Bye now.